Okay, so the first way that we are going to look at summarizing how spread out a data set is an idea called the MAD, or the mean absolute deviation. And this is covered in our middle school standards currently. And it's like, if you've ever heard the term standard deviation, we are not doing standard deviation, but the MAD is like a baby version of standard deviation. It's actually something that we can make sense of. So let's unpack first this phrase, like mean absolute deviation, because once we unpack it, I think we can actually make sense of what that phrase is trying to get at. So mean absolute deviation is the mean of the positive differences from each data point to the mean of the data set. So we have the mean of our data set, and that in this case is 3. And each data point has a distance from that mean. We're not going to care about positive or negative. We're just going to talk about the distance or the difference. So we will look at that. And then once we have all those differences or distances, we're going to find the mean of those. And that's going to give us an average distance that the data points are from the mean of the data set. Okay, so let's look at this. So we have our data set listed out at the top of the screen. And then we have a dot plot of our data set. And we have the median and the mean highlighted on the dot plot. For now, we're going to leave the median alone. The MAD has to do with the mean, and the distance is from the mean. So just ignore that blue median. For now, it's there, sitting there at 2.5. But we are going to focus on the mean, which is exactly 3 for this data set. Okay. So let's start to think about, for each of these individual data points, how far away from the mean are they? So if I look at like this data point right here, that's a 1. And so it is 2 away from the mean. So I'm just going to denote this with a little 2. And that's the same with everybody in this column, right? They're all a data point of 1. These are our 4 data points of 1. And they're all 2 away from the mean of the data set. And then similarly, all these here are just 1 away from the mean of the data set. They're all data points of 2. And then these all are exactly on the mean. So these are all just like right there. There's no distance between their value and the mean. So those are all zeros. Then we don't happen to have anything at 4. For 5, again, we don't care about direction here. We just care about distance. So these are all 2 away, because 5 is 2 away from 3, that mean. And then lastly, we have our 6s, and these are both 3 away. So now with these distances or differences, we can calculate the mean of them, and that will give us the mean deviation from the mean of the data set. Okay. So I'm going to find the mean of these by just adding them up. So let's do our little calculations here. I'm going to write this all out. Just for the sake of having a nice complete example. So you can imagine a little like, I'm just using this space over here just as whiteboard space. I'm not actually on the graph anymore. So 2 plus 2 plus 2 plus 2, I'm getting those from over here. And then I have my 6 ones. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I could add in my zeros. I could show plus 0, plus 0, plus 0, plus 0. Let's go ahead and do that just for this example. 2 plus 2 plus 2 plus 2. And then lastly, I have my 2 3s. Okay, so that all together, I can think about how am I going to add that up? So I know 4 2s is 8. And then I have my 6 ones. That's just 6. I have all my zeros. That's 0. I have another set of 4 2s. So that's another 8. And 2 3s, which is another 6. Oh, that's kind of neat. 8 plus 6 plus 8 plus 6. Okay, so I'm going to think about this as 8 plus 8 is 16, plus 6 plus 6 is 12. So 16 plus 12 gives us 28. So that's the sum of all of these distances. And now I need to remember to divide by the number of data points that I have in order to get the mean of these distances. So this is, we'll call this step A. That's an A. And then the step B right there. So 28, that's the sum of those distances, and then divide by the number of data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16, 17, 18, 19, 20, 28 divided by 20. So I can tell that my MAD is going to be greater than 1, but less than 2. It's 1.4. So this is the MAD of this data set is 1.4. And what that tells us is that on average, the data points are a distance of 1.4 away from the mean of the data set. So that is useful information to have if you're working with, let's say, like a really big data set. With these examples where we're looking at data sets that's just like we can calculate this almost by hand and we can see all the data really clearly, it feels a little silly of like, why am I calculating all of this? I can see how far spread out the data is. It's like, it's obvious. But when you start to think about real life data sets and the data that statisticians use and data scientists use, it's like they have data sets that are like 10,000 data points or 10 million data points. And so looking at a list of all the data points isn't actually very useful, or even a graph isn't very useful sometimes. So we have these ways of summarizing characteristics of the data set. We had mean, median, and mode to characterize the center of the data set, or what's typical of the data set. And then you can add in things like the MAD, which tells you how far away from the mean on average those data points are. If our MAD was instead 10.4 instead of 1.4, then I would know on average the data points are 10 away from our mean, or 10.4 away from our mean. That doesn't mean they're all 10.4 away from our mean, but it would mean that the data would be a lot more spread out than what this data set is. And so numbers like that can be really valuable, especially when you're working with like large data sets. But then there's also value to looking at small data sets because we can actually calculate these things and then make sense of the numbers and like where they're coming from. Okay, so that is your introduction to mean absolute deviation. And this is also described in the text, and there are a couple of examples in there as well. Okay, so we just looked at a way to summarize the spread of the data by looking at the mean and the MAD. And now we're going to look at a totally different approach for summarizing the spread of the data. And not to say that one is necessarily more useful than the other, it's just another way that you can try to make sense of how spread out your data set is. Okay, so this is a 5-number summary, and we're also going to visually represent that 5-number summary with a box plot. So this is actually the same data set that I had for calculating the MAD. I haven't changed it. And let's start by talking about what is a 5-number summary. 5-number summary helps us chunk the data into 4 pieces. Okay, so let's see how it does that. So always the parts of the 5-number summary are the minimum, the 25th percentile, the median, which is also known as the 50th percentile, the 70th percentile, and the maximum. Okay, so the minimum would be the least data point in this data set. And this is right here. I've zoomed in a little bit, so now it's not showing tick marks for every one, it's showing tick marks for every 2. So we know that that's halfway between 0 and 2, so this is a value of 1. You can go ahead and fill in this as well. Okay, so the minimum data point, the value is 1. Okay, we have the median here plotted for us. The median is the 50th percentile. It cuts the data right in half as far as if we were to list out all the data, least to greatest. and we were to see what is the exact middle data point, or what's the middle of the two middlemost data points if you have an even number of data points. Okay, so that is, it looks like 2.5 here. The maximum value is the highest value that we have, and that's 6. Okay, so then let's start talking about how we can know the 25th percentiles and the 75th percentile. So I can actually read this off of my box plot. So this is the minimum. This is the maximum. This is the median. And then I have my 25th percentile and my 75th percentile. So 25th percentile. So that is right here at 2. And then the 75th percentile is there at 5. Okay. So what if I didn't have the box plot already? What if I was like going to try to figure out what are these percentiles and what do they mean? How do you get them? So the 25th percentile is the median of that first half of the data. So I'm taking the minimum to the data set's median and I'm cutting that in half. And that'll give me the 25th percentile. And likewise, if I looked at the other half of the data, the median to the maximum, and found the median of that, then that would tell me the 75th percentile. So usually finding these would involve listing out all the data points or using a computer to help you find those values. But let's look at what this box plot is actually showing. So we notice that it's not that all of the parts of it are the same length on our number line. So the cool thing about a box plot is that it's got 4 sections. Let me see if I can highlight these 4 sections for you. So it's got like this section, and then it's got this first part of the box, and then it's got this second part of the box, and then it's got this last section here. So let me label those. Maybe I can do like little brackets there. So the box plots look kind of funny, but really what you need to see them as is just showing you 4 chunks of the data. And in each of those 4 sections is a quarter of the data. Let that sit with you. In each of these 4 sections, so 1, 2, 3, 4, lies a quarter of the data. What the box plot is telling us is how spread out each quarter of the data is. So if I want to ask, like, how spread out is the quarter of the data that's between the median and the 75th percentile? Oh, it's the most spread out part of the data. It is goes from 2.5 to 5. And you can also look at something called the interquartile range. Sorry for my squeaky chair there. If you can hear that. The interquartile range is the range of the middle half of the data, which you get by subtracting the 75th percentile from the 25th percentile. So you're looking at the range of the box. What is the spread of that box? Okay, so let's see. In this case, my 75th percentile is 5. And I want to subtract from that the value of 2, because that's my 25th percentile. And so I'm going to get an interquartile range of 3. So the interquartile range is 3, and that's just, got a lot of yellow going on here now. That's just the range of the 25th percentile to the 75th percentile, and that middle half of the data. It's just telling me how spread out is the middle half of the data. It spreads 3. It ranges 3. We know it goes from 2 to 5, and thinking about how far that is, that's a distance of 3. Okay, so we've looked at the 5-number summary and the box plot and the interquartile range, and there's a lot more examples in the book and also in the homework problems. All right.